Hi folks, we're going to take a look at a couple of examples using L'Hopital's rule. So we know that L'Hopital's rule helps us deal with indeterminate forms 0 over 0 and infinity over infinity. So we're going to take a look at a couple of other indeterminate forms. We're going to start with 0 times infinity. Okay, so we'll take a look at the example. Limit as x approaches 0 from the right of x ln x. So we have that x is approaching 0, ln x is approaching negative infinity, and as usual, is there one of these that's going to take over as we get closer and closer to 0? This one's pretty easy because all we're going to do is just rewrite the expression so that it will give us an indeterminate form, in this case here infinity over infinity. And we just do that by rewriting x as 1 over 1 over x. So let's do that here. We have limit as x approaches 0 from the right of ln x, and again we'll just write x as 1 over x. And so now we have the indeterminate form infinity over infinity, hence we can apply L'Hopital's rule. So let's do that. Limit as x approaches 0 from the right, take the derivative of the top, 1 over x, and take the derivative of the bottom, negative 1 over x squared. Do a little bit of quick algebra here. So those cancel out. We end up with negative x. And so our limit is equal to 0. Okay, we'll even take a look at the graph here. Graphing calculator, turn that on, and we'll see here, if you look, we have the graph of x ln x, and as x approaches 0 from the right, the function indeed approaches 0. Okay, now we'll take a look at a second one. We'll take a look at the form infinity minus infinity. And the example we'll take will be the limit as x approaches pi over 2 from the left of secant x minus tan x. And we see that secant x approaches infinity and tan x approaches infinity. So again, will one of these take over, or will they reach some happy median? Okay, so the way we deal with these type of examples is you try to find, again, some way to rewrite it in the form 0 over 0 or infinity over infinity. And so here we're just going to do some algebra, do really what's I'd say the only possible course of action. So turn secant into 1 over cos, and then turn tan into sine over cos. And we can do some very easy algebra here. So limit as pi over x approaches pi over 2 from the left, and we've got 1 minus sine x over cos x, and lo and behold, we have 0 over 0. Oops, 0 over 0, of course. And so now we can apply L'Hopital's rule. So limit as x approaches pi over 2 from the left. So take the derivative of the top, we've got minus cos x, and here we have minus sine x. And we realize that we just have 0 over 1. So that's just equal to 0 again. And in fact, let's check the graph of this one here. So let's go back. And if we take a look at this graph as x approaches pi over 2 from the left, the resulting graph indeed does approach 0. Okay, so again, our rationale in these two examples is to take the expression that we have and rewrite it in the form that'll give us either 0 over 0 or infinity over infinity.